just graphing 4 different linear inequalities at the same time. Okay, so maybe I can color code these. That'd be easier. Let's pretend this just says x plus 2y equals 14. Let's graph that. Okay, so we got your only doing the first quadrant. Oh, sorry, and I should have emphasized that. We're doing the first quadrant because it says x is greater than or equal to 0. So these numbers over here. Okay. Oh, let's clear that. X is greater than or equal to 0, and y is greater than or equal to 0. So that's why we only need to worry about graphing it in the first quadrant. Okay, so if we graph this green equation here, it's probably quickest to graph using the intercepts. Plug in 0 in for x, you get y is 7. Plug in 0 in for y, and you get x is 14. So this is a dot at 14 comma 0, and this is a dot at 0 comma 7. So our graph connects those 2 points. And it's a solid line. You would usually use dotted lines if they had just less than instead of less than or equal to. Okay. And then we got x plus y is less than or equal to 9. So let's graph this one. If you plug in 0 in for x, you get out 9 for y. If you plug in 0 in for y, you get out 9 for x. So we're going to put a dot at 9 comma 0. And then a dot at 0 comma 9. We can draw a line. Oops. Draw a line between those two. And you can see these two lines are giving us some regions. We got, if I drew the straight line, this would be a triangular region here, triangle here. We got a polygon over here, and then another open-faced area that never ends out to this direction. So we got to find out where we can have valid solutions for this problem. Okay, and the way you can do that is you can do it by plugging in some test points. So let's say you just need to pick some points within these triangle regions, within each of those 4 different regions we just described. So like if you want to plug in like 1 comma 8, that's going to fall within this region somewhere. Okay, and so if you plug in 1 comma 8 into this top inequality, 2 times 8 makes 16, 16 plus 1 makes 17, 17 is not less than or equal to 14. So that gives us a not true statement for this top inequality. So that means we don't shade this area. That's not a valid solution. It would work from the bottom. Well, yeah, it would technically work for the bottom one. I think it's actually going to land on the line. But that doesn't mean it's a solution. Okay, it has to work for both of them because it's a system of inequalities. So that's not our solution area. Let's try picking a point somewhere in this region. Let's do like 10 comma 2. Something that confidently falls within this region. Again, plug it into the inequality. 10 plus 2 times 2 makes 4. 10 plus 4 makes, here. Let's just make it more clear. Let's do 10 comma 1, okay? A little bit lower. If you plug in 10 in for x and 1 in for y, 10 plus 2 makes 12, and 12 is less than or equal to 14, okay? If you plug in 10 here and 1 for y, 10 plus 1 makes 11. 11 is not less than y. So it works for the top, not for the bottom. So this is in our region. This is in our region. Let's find a test point somewhere in here. Let's just say something easy like 1 comma 1. 1 for x, 1 for y. You get 3 is less than 14. That's true. 1 plus 1 is 2. 2 is less than 9. That's true. So this is going to be our solution region. You could pick a test point out here, but any point you pick out here is not going to be a valid solution, okay? This is our region, so let's see if we can tell Newton that. Starts at 0, 0, okay, because we said it's only the positive values of x, positive values of y. Goes all the way to 9, that region that we shaded. Goes all the way up to 7 on the y-axis. Oh, I don't want that straight line. It switches directions here. We need to know what this vertex is. And you can find that vertex, so we're going to want to, I'm just guesstimating right now. You can find that vertex by taking these 2 inequalities and solving them as a system of equations. X plus 2y equals 14. X plus y equals 9. And then you can solve that with elimination real quick. And if you need help with that, check out the other videos on elimination. But I'm using multiplying everything by -1. And then when you add the 2 together, you get y equals 5. And then if you plug that back in, you get x equals 4. So it's going to cross, this crossing point right here is 4 comma 5. Okay, 4 in the x, 5 in the y. Oh, and I guessed right. That's the dot. Okay, so that's a point in our region. And when we said 0, 7 was also a point. Oh, there we go. And now we want it to come all the way back down to the start. Huh, I can't believe I got that in the first try. That's our polygon. So really you just click the vertices, the 4 vertices, and Newton will draw the polygon for you.